Okay, Assalamu alaikum again. We're starting the tutorial. This is the tutorial videos, which is for worksheet, I believe, number 5 or 6, which is basically deals with the circuits and deals with mainly with Kirchhoff's rules, Kirchhoff's rules number 1 and Kirchhoff's rules, or rule number 2. And if we quickly go over that, we have 2 or 3 things that we have to make sure that we understand. And whenever I have a circuit, then the first thing that I must observe is that the sum of the voltages around a closed loop must be equal to 0. And I think we defined what a closed loop is. So you start from a point, then you go through the different circuit components, resistors or batteries or capacitor or anything, and then you go around a loop, and that should give you the sum of the voltages. The voltage increase must be equal to the voltage drop, so that you get the sum is equal to 0. And the other rule, or the second rule, the sum of i's around a point or a junction must be equal to 0. So that means the currents in must be equal to the currents out. And then we have the third point is that the power is defined as I squared R or IV if you want. Okay, so it's either that or IV. If you say V is equal to IR, then this is easily seen. And the other thing that we have the combination of resistors. We have the series combination in which R equivalent is equal to R1 plus R2, and the parallel combination in which we have 1 over R equivalent is equal to 1 over R1 plus 1 over R2. And this will give me an increase in the resistance, and this will give me a decrease in the resistance. So I think that's all. And the other thing that we need to know is that when you're doing series combination, the current here is the same, but the voltage is not. And if you're doing parallel combination, the current is not the same, but the voltage is the same. Okay, so keep that in mind. Here the current is the same, but the voltage is not. Here the voltage is the same, but the current is different. Okay, so these are the things that we have to keep in mind, and this is basically a summary of everything that we're going to use in solving this worksheet. Okay, let's start. So the first problem we have is the problem says that I have this circuit, and what he wants when the current moves in the direction of the how much power being dissipated in the 10 ohm resistance. So it's one of these resistors here. So how much power is dissipated here and how much power is dissipated there. Now in order to do that, I have to use this equation here. So that means I have to find the current in each of these resistors. The way I do that, I first look at the combination of these resistors, there are 3 of them. So 1 over R equivalent is equal to 1 over 20 plus 1 over 10 plus 1 over 10, and then I get the equivalent of that resistor, and then I will have this simpler circuit, which I can definitely find I here by simply using the sum of the voltages equal to 0, and then I say 12 minus 2I minus the combination of these, which is I don't know what it is, but I don't know what you have to work out the combination of these resistors, and then that is also I, and from here you get I. Once you get I think I got the value of I. I don't know, maybe it's equal to 2 amps. If my calculations are correct. So the current here is 2 amp. So this is 2 amps and 2 amp. So that means I can calculate V in this combination. So V is equal to I R, and R is this one here. R is this R equivalent. And once I do that, that means V here, the one that I calculated, is the same for these 3 guys as I just said earlier. So V will be the same for all of them, and from here I can find I here, and I here. Simply V is equal to I R, and then I is equal to V divided by R. for each one of them, and then I get an I here, an I here, an I here, and then I can calculate the power dissipated in any of these resistors. Okay, so this is the solution to question number 1. Question number 2. Question number 2, which is I have this resistor. By the way, in question number 1, when the current moves in the direction of the electric field, so that means it's just what he's saying, that you're following the direction of the current. Yeah. Okay, so now in question number 3, if this is 20 V, okay, so 20 volts, and what's the thermal energy being generated in the 20 ohm resistor? So he wants the power, thermal energy generated, that means the power in this resistor. What's the power in this resistor? Again, in order to find the power, I have to find the current here, so that P is equal to I squared times R. In order to find that, I have to combine these three. Okay, so I combine these three, 1 over R equivalent will be equal to 1 over, is it all of them 30? So 3 over 30. Okay, 3 over 30, that means R equivalent is equal to 10 ohms. Okay, that means my circuit now is reduced to this. Okay, and this, and this, and this. And from here, that's 40, and and this is 10 now, and this is 20. So from here I can find, from the sum of the voltages equal to 0, I can find the current here, which is simply 20 minus 40 I minus 10 I minus 20 I is equal to 0, and I can find I. And once I find the current, which is in this case, this is its direction, so I can find the current, and from here I can apply this equation and find the V is equal to, the power is equal to I square R. Okay, and that's it. That's the solution to question number 2. Okay, the following question, which is question number 4, that is a straightforward question. I'm not going to bother with it, because it's just simply you have to what's the potential difference per unit volume, and you have given the resistivity and the current. So from that you can calculate the resistance, and once you calculate the resistance, then you calculate the voltage V is equal to IR. Let me move to question number 5. Okay, question number 5. Question number 5, I have this circuit. I forgot to put here 12 volts. Okay, and this is 4 ohms. Okay? And what does he want? What's the equivalent resistance of the circuit shown? That's very simple. So all I have to do, I combine these two in series. So these will be 3, and these guys will be 6. Okay, and then I combine these in parallel. So 1 over 3 plus 1 over 6 is 1 over R equivalent. I find that, and then I combine these with this in series, which is so it's very straightforward. You don't have to do any calculations to find whatever the solution is. So it's just simply, just working your way from, as I said, first you combine these, and you combine these two, and then you combine those as series. Okay, so that's question number 5. Question number 7 is the question here is dealing with capacitors, which we've done that before. He just wants to find what's the equivalent capacitance. You just have to do that just like what we did before. I'm also going to skip that because we've done that and we have been